Okay, this is induction type 1. I'm only going to do from the assumed and to prove onwards. So you do need to do the first step yourselves and all proofs. You can't leave out the steps. So prove it for n equals 1 first. So I'm looking at the first question 1. 2 plus 4 plus 6 plus 8 plus, remember this part explains how it works. So this is really what what you want to prove. So sometimes you see all this extra notation. Don't worry about it. This is what you want to prove. Okay, so let's start with our assumption. I'm assuming that you're doing n equals 1 and you're proving that's true. So assumption that 2 plus 4 plus plus 2 times k is equal to k times k plus 1. Okay, we'll keep an eye on that now for our assumption. We need that to kind of appear somewhere. So we start and then we go on to our to prove. Okay, to prove. Oh my god. To prove that 2 plus 4 plus plus 2 times k plus 1 equals to k plus 1 times k plus 1 plus 1. Okay, if you want you can work this out further down to spare a line at the end, but it's going to cost you a line either way. Alright, so what do? We start with our assumption. So 2 plus 4 plus plus 2 times k equals k times k plus 1. That is what we have assumed. Okay, if that's what we've assumed, therefore I'm just going to turn the left side into what I want to prove by going on to the next term. So 2 plus 4 plus plus 2 times k plus 2 times k plus 1 is equal to, so all I've done onto my assumed is add on the next term, so I must add that on to the right of what I've assumed as well, plus 2 times k plus 1. Okay, last time I'm going to write the left hand side, 2 plus 4 plus plus, I'm just going to use my last term, 2 times k plus 1. That 2 times k is still there, it's before this term, but I don't have to write it. So now this left hand side is exactly the same now as what I have to prove. Now I just need to make my right hand side the same as what I have to prove. In these ones, we're just going to work on multiplying out our brackets here. So k times k is k squared plus k plus 2k plus 2. So tidying that up, that's k squared plus 3k plus 2. And factorizing that out, that is going to be k, and it's going to be 1 and 2. And that's almost perfect, except I just need my k plus 2 to look like this, k plus 1 plus 1. So it's k plus 1 multiplied by k plus 1 plus 1. Make sure you do the ending, hence true for n equals k plus 1, hence it is true for n equals 1, hence it's true for n equals 1 plus 1, and so on. Look at that in the book, because you have to have those conclusions in to get any amount of decent marks in here.